Hi, Jasmina. Jasmina, can you hear me?
Hello.
Hi, Kevin.
Howdy.
You're talking to me.
Hello.
Jasmina, you there?
Yeah, I'm here. Hi.
Okay. Yeah, just a little bit delayed. No problem. We doing okay, guys?
Yep.
I'm doing well. How are you?
Any problem with the quizzes or anything?
Nope.
No. I keep getting 80%.
Well,
I
maybe
miss
you're an
2 questions.
80% kind of guy.
I'm not normally. It's frustrating.
Sorry, Kevin.
I'll figure it out. It's early yet.
It takes a while to get used to the way I ask questions.
You word them much differently than I'm used to.
Sorry.
Sometimes I miss like weird things.
I think it has to do with my English degree. That's what I'm blaming.
One of your questions only had one answer choice.
Yeah, that was my favorite.
What's that?
One of your questions only had one answer choice.
Wow.
Yep, everyone got that one right.
I think it was number 7. Or something.
Well, I'll tell you what. If you got that one wrong, then you flunked the course. Which one was it, you know?
I think it was like 5 or 6. Was it? It was a charge. It was the first charge question.
Okay, let me.
Yeah, I remember the answer was like CaCl2.
Yeah, that's what it was too.
Oh, was it the calcium one?
Yeah.
Yeah.
Damn. Okay, quiz 5. Was it quiz 5 or 4?
Yeah, I think it was
4. I think.
Okay. Hi, Gabe. How you doing?
Good. How are you?
Peachy Keen. Wonderful. Just happy to be here. Okay. Let me go in here and see. Edit. Okay. Oh, this one? I'm sorry, you're not seeing this.
No, we can't see your screen.
Ah, what a crock. Well, that's it. If you missed this question, you flunk. Things happen. You like that question, huh, Kevin?
I loved it.
More. You want more like that one, huh?
Yes.
All right, let's see if I can get my screen up a little higher. Am I in here or not? You seeing? Nope. Are you seeing me?
Like half of you.
Half of me. Better? Because I'm not seeing me.
Yeah, that's good.
That's good. If you want to see me, I mean. Okay, guys. Let's see how many of you. I got 6 of you in here. At least that's better than I did 2 times ago. Yeah, and Gavin will not be joining us because he's had a change in work schedule. So, oh well. All right. So, did I just get rid of everybody?
No, we're here.
You're still here? Okay. I am still. Am I still screen sharing?
Yes.
Yeah.
All right. I just took it off. I'm going to put it back on again because, oh, there I am.
There you are.
Okay, guys, we're going to go through some periodic trends, and I'm hoping to go through them fairly quickly, all right? Now, when we're dealing with something, we're dealing with electronegativity, all right? Electronegativity is the ability for a substance, for an element to pull in an electron. And basically the numbers you see on the screen right now, they're just relative numbers. They're relative to to one another. And so if you have a compound that's on the left side of the periodic table, that means they have more or less electrons, Vera.
On the left side,
If it's on the, I'm sorry, the right side.
right side, they have more.
More electrons, okay? So they're closer to 8. So these compounds that are on the right side of the periodic table want to really grab electrons, so their electronegativities are going to be very, very high, okay? On the other hand, if you look at something like francium, we have 1, 2, 3, 4, 5, 6. Its one electron is 7 orbitals away from the nucleus. It's far, far away. So francium doesn't have the positive power because it is so far out there. Francium doesn't have the positive power to pull in another electron. So its electronegativity is very, very weak. Electronegativity increases from left to right. Electronegativity increases from bottom to top. So the most electronegative is going to be fluorine. The least electronegative is going to be francinium. Okay? Make sense, guys?
Yes.
Yep.
Okay. Jasmina.
Yes,
Jasmina?
hi.
Hi.
Hello.
We have nitrogen, bismuth, and arsenic.
Yes.
Bismuth, nitrogen, arsenic. Which one is the most electronegative?
Nitrogen.
Next.
Arsenic.
And then bismuth. Okay.
Yeah.
All right. We're going to go bromine, potassium, and copper. Bromine, potassium, and copper. And let's see who I can get. Ian. You out there, Ian?
Yes. Can you hear me?
Copper,
Okay.
potassium, and bromine. Which one is the most electronegative?
Bromine?
The next one to bromine, potassium or copper, which one is more electronegative?
Potassium.
Okay, remember, Ian. Remember, as you go towards the right, as you go to the right, you have an increase in electronegativity. Now, do you want to give me another guess between potassium and copper?
Copper.
Copper has more electronegativity than potassium does.
Okay, yeah, I see that now.
I
My
lost
bad.
somebody. Who did I lose? I don't know. Cassidy, you're there.
Yes.
Cassidy?
Yes.
Okay. The next one is going to be. Next one is going to be fluorine, oxygen, and polonium. Which one is the least electronegative?
Oxygen.
Between polonium and oxygen, which one has orbitals way out there, Cassidy?
Oh, polonium.
So does polonium have less positive power to pull in another electron?
Yes.
So between polonium and oxygen, which
It's
one is the least electronegative?
polonium.
Then between oxygen and fluorine?
And then it's oxygen, and then fluorine's the most electronegative.
Absolutely. Okay. Guys, I promise you this. When I give you an example on the test, I promise it will be easy to determine what it is. In other words, I'm not going to give you something like choosing between selenium and phosphorus, because selenium is one to the right of phosphorus, but yet it's one down from phosphorus. So you can't really tell just by looking at the chart which one is more electronegative. Does that make sense to you?
Yes.
What I will do is I will ask you something like lead, germanium, and bromine. Okay, you know the difference between lead and germanium is lead has more orbitals, so it's going to be less electronegative than germanium, and germanium is to the left of bromine. Okay, fair enough, guys?
Yes.
Okay, another one that's similar to electronegativity, but it has a little bit of a difference to it. What ionization energy is it's the energy required to take an electron away from an element. Ionization energy is the energy required to take an electron away from an element. So, because fluorine has only out to the second orbital, and it's as far right as you can get without being a noble gas. As you go from left to right, you increase the energy it takes to take an electron away. As you go from bottom to top, you increase the energy it takes to take an electron away. Francium, if you want to think about this, francium has its lone valence electron way out there. It doesn't feel the positive energy as much as hydrogen, which has its lone electron in the first orbital. So as you go up the periodic chart, ionization energy increases. As you go from left to right, ionization energy increases. Let's go with Kevin. You there, Kevin?
Yes.
You dropped out for a while. If I'm going to ask you, rate from least ionization energy to most between calcium, arsenic, and bromine, which one has the least ionization energy?
Calcium.
Next. I think I said arsenic and bromine.
Bromine and then arsenic.
Nope. Kevin, ionization energy increases as you go from left to right. So if you're choosing between arsenic and bromine, bromine is further to the right. It's going to have a higher ionization energy than arsenic. Make sense, Kevin?
Yeah. Yeah.
So it goes from least to most: calcium, arsenic, bromine. Okay. Let's see who else is in here that I haven't picked on yet. Gabe.
Yes.
Gabe, you there?
Yes, I'm here.
Okay, Gabe. Antimony, phosphorus, and nitrogen. Which one is the least electronegative?
All right. Is it?
I don't know. It's a perfectly good answer, Gabe.
Wait, what'd you say again? Antimony. What else?
Antimony, SB, phosphorus,
Okay.
and nitrogen. Which
Oh,
one
okay.
is? Which one's the least electronegative?
Oh,
Oh, I'm sorry. Which
antimony.
one has the least ionization energy?
Antimony.
Next,
Phosphorus.
last.
Nitrogen.
Okay. Now, last one. And I'm going to see who I can pick on now. Jessica, you there, Jessica?
Yes.
Okay. You have the hard one. Barium, magnesium, and phosphorus.
What was the first one?
Barium
Oh, barium, magnesium.
and phosphorus. Which has the least ionization energy?
Barium,
Then
magnesium.
keep on going.
1 second. I'm trying to find phosphorus.
It's on the screen. Are you looking at the
Oh,
screen?
yeah, it's barium, magnesium, and phosphorus.
There we go. Okay. Now, atomic radius is going to be a little bit of a, it's a little bit harder to understand than the other two. We can understand that these guys all want to have more electrons because it's easier for them to be on 8, an octet. So it really, these guys that understands electronegativity and ionization energy are easily understood. Atomic radius. As you go down periods, as you go down the rows, what you are doing is you're adding one more orbital. So if you're adding one more orbital, the element is becoming larger and larger. So as you go up the periodic table, your atomic radius is getting smaller. Now, what's not clear, that seems fairly clear. What is not clear is the fact that as you go from left to right, your atomic radius gets smaller itself. And that makes sense if you think about it, because each time you're moving an element over, are you not adding another proton to the nucleus? So fluorine has 9 protons in there. Lithium only has 3. So there's more positive power from the fluorine. That positive power kind of sucks the electrons in a little bit. So as you go from left to right, the elements are getting smaller. As you go from bottom to top, the elements are getting smaller. Jessica, you're there. Strontium, tin, and iodine. Which one has the smallest radius?
Iodine.
Next. I think I said strontium, tin, and iodine.
10.
And last.
Strontium.
Very good. Okay. You're off the hook. Vera.
Sir,
Vera?
yes, sir.
Okay. You've got aluminum, indium, and whatever the hell TI is. I don't even know what TI is.
Looks like TI is thallium. All right, so you said aluminum.
I want smallest to largest.
So you said it was aluminum, indium.
TI and IN.
Okay. So smallest would be aluminum, and then indium, then thallium.
There we go. That's thallium? Okay, I'll trust you on it.
Yeah.
I'll
I
trust
thought
you
it
on
was
it, Vera.
titanium.
What's that?
I thought it was titanium, is it
Yeah.
not?
Yeah, I think it is titanium.
Oh, shoot.
Oh,
I'm looking at TL, I think.
hold on one second, guys.
Oh, that's T. Yeah, because TI is in the middle. Yeah. So shoot, then it'd be.
Okay, yes,
So it'd be aluminum, indium, and then titanium.
yes. Yes. Thank you very much. I'm sorry I'm teaching a class right now. Thank you. Bye. I'm sorry, guys. That was something I had to take. Okay.
No worries.
Oh, good. Jasmina, you popped up.
Yes, hi.
Jasmina, cesium, sodium, sulfur. Which one is the smallest?
Oh, sulfur.
Next.
Sodium,
And what's the largest?
cesium.
There we go. Okay. Now, guys, one of the properties I mentioned, electronegativity, is important when we're getting into bonding. All right. If there is a difference in electronegativity, 2.0 and up between the two elements, you've got an ionic bond. Basically, what we are dealing with is we are dealing with a metal and a non-metal. You have to have a metal and a non-metal to get the difference in the electronegativity to be that great. If it is between 0.3 and 1.9, you have a polar covalent bond. A covalent bond involves sharing the electrons, but they're unequally shared. The electron spends more time around one of the elements than the other, which gives it a pseudo-negative charge for the one that the electron spends more time around. So if we have H2O, The H and O, the oxygen isn't powerful enough to steal hydrogen's electrons, but it is powerful enough to have the electrons spend most of the time around the oxygen. So if we have water, the oxygen portion of the molecule is negative. The two hydrogen atoms are positive. So you have a change in the charge within the entire molecule. Then if you have the electronegativity almost equal to one another, you have something called a nonpolar covalent bond. Now, what we're talking about is we're talking about the valence electrons. We don't care about the electrons that are on the inner orbitals because those electrons are not going to be disturbed by anything. The only electrons that get involved in bonding are the electrons in the outermost shell. Those are the electrons that are at the highest energy. They're held the loosest. So the valence electrons are the ones that are going to determine the properties of the atom and by proximity, the way that an atom is going to bond chemically. There's something we call the octet rule, except for hydrogen and helium, which have 2 electrons and they're satisfied. All the other elements in the periodic chart want to have 8 in their outermost shell. If they have 8, they're happy. Kevin, do you like pizza, Kevin? Kevin may not be here. He's been popping in and out.
I like pizza.
You like, thank you, Kevin. Now, Kevin, you have 8 pieces of pizza. Are you sitting on your couch rubbing your belly?
Most likely.
Or puking?
Depends on how much beer I had.
There we go. So you have 8, you're satisfied. So if elements have 8 electrons, they're satisfied too. Okay? Now, there are 2 ways to make 8. You could increase the number of electrons to 8. You can give up electrons to have 8. The magic number is 4. If your valence electrons are bigger than 4, they will grab electrons to make 8. If your valence electrons are less than 4, they will give up electrons. Jasmina, do you like kids?
Eh.
Do you like kids?
Not really. They
Oh,
kind
you
of
hate
annoy
them,
me.
right? You're
Sure.
like me, you hate kids. If you have a couple,
Yeah.
if you have a couple, you're looking for the nearest church to lay them on the steps, right?
Sure.
Okay, good. Now, that's fine. Jessica, do you like kids?
They're okay.
Yeah, you're a carbon. Layla, do you like kids?
Sure.
Okay. Layla, what you're going to do is you're going around. You're hopping around St. Petersburg and you're looking at every church to see if somebody has dropped off kids. And you're going to grab them and you're going to put them in and you are going to nurture them for the rest of their lives. On the other hand, Jasmina has given up her kids. Elements are the same way. If the elements have more than 4 valence electrons, they are going to grab some more kids. They're going to grab some more electrons. If the element has less than 4, it's going to give up the kids. So does that make sense, guys? Make sense?
Yeah.
So if they give up electrons, there are less electrons around the element than there are protons. If they give up electrons, the element is positively charged. It's called a cation. If they grab extra electrons, that means there are more electrons than there are protons. The element is now negatively charged. That is called an anion. Now, as you go across the periodic table, with each element, you add 1 electron. When you go down the period, you start all over again at 1. Jasmina,
Hello.
forget about hydrogen. Lithium, do you have a periodic table near you?
No, but I can pull one up real quick.
Okay, pull it up real quick. Guys, pull up periodic tables. Question you have, Jasmina, is lithium. What is lithium's charge? Let's in show. Okay, Jasmina, if you don't have it, let's look at this. Lithium is right here. Lithium is right here, Jasmina. Look at the screen.
+1.
Plus one. Okay. We have calcium. And we're going to go Layla with that one. Calcium. Calcium is right here, Layla. What is the charge on calcium?
+2.
+2. All right. We're going to go with, grab Cassidy. We're going to go with selenium. And I don't know why this thing is here. I'm going to cut. There we go. Selenium. Cassidy.
-2.
-2. Okay. Okay, we got that. We got that. All right. Yeah. Formation line. Okay. Now, there are 2 types of chemical bonds that we're going to deal with here. The first type is called ionic. The second type is called covalent. And basically, let's look at this like communism versus capitalism. If I am talking about capitalism, what's mine is mine and what's yours is mine too. This means that you're going to have elements that have the ability to grab electrons from other elements so that they're going to grab them and keep them all to themselves. But you have one that's gotten extra electrons, so it's a negative charge. You have another that has lost an electron, it's positive. Negative and positive bind together. We have an ionic bond. On the other hand, we could have the real nice 60s. Remember the 60s, guys? No, of course you don't. You weren't back there. I was. In the 60s, we had these people that were developing communes, and what they would do is they would put all their wealth into one big pot, and people would just grab what they needed when they needed it. That's what a covalent bond is. Covalent bonds involve sharing electrons. Now, there are 7 elements that exist as diatomic molecules. So I have a mnemonic. Have no fear of ice cold beer. These 7 elements do not exist as one atom. They exist as 2 of them bonded together. Have hydrogen, no nitrogen, fear fluorine, of oxygen, ice iodine, cold chlorine, beer bromine. All 7 of those exist as diatomic. In other words, 2 atoms bonded together. You will never see a Cl out in the world by itself. You will never see an O by itself. They will be bonded together with another one. Okay, guys, I'm going to stop share. I am going to call up a video. It's my favorite video that I do. My favorite of all time. I just have to go find it. Yeah, there it is. Okay, fall 2020. First test. It's loading. Okay. Did you like the dog video the other day? Did I show you a dog video the other day?
Yes.
Yes, it was cute.
This one's even better. Okay, I got to get in here. Share screen. Share sound. Optimize screen for video clip.
Welcome to Dogs Teaching Chemistry. Our first lesson is chemical bonding. Chemical bonds are what holds atoms together. A chemical bond is an attraction between atoms that allows the formation of a chemical substance. The electrons that participate in a chemical bond are called valence electrons. These are electrons that are found in an atom's outermost shell. Let's take a look at the types of chemical bonds that can be formed between atoms. An ionic bond is formed when one of the atoms will lose its electron to the other atom. This results in a positively charged ion, called a cation, and a negatively charged ion, called an anion. Positive and negative attract, and the result is an ionic bond. Covalent chemical bonds involve the sharing of a pair of valence electrons by two atoms. There is also what is called polar covalent bonds. These are covalent bonds in which the sharing of the electron pair is unequal. The result is a bond where the electron pair is displaced toward the more electronegative atom. Thanks for watching, and we'll see you guys next time.
Okay, 2 minutes. It took them 2 minutes to do that, and you probably understand it better from those dogs than you do from what I've said. Oh, crap. Okay. Okay. All right, we good, guys?
Yes.
All right, now we're nearly caught up, guys. Okay, I teach this a little bit differently than probably some other people. All right. Now, if you have, and I'm going to add a slide here. If you know that aluminum is a +3 and oxygen, nope. Oxygen is a -2, right? You guys have probably been taught, okay, all you got to do is cross them and that will give me my subscripts. Is that correct, guys?
Yeah.
Yeah.
It works until it doesn't. Okay? For example, if I were to do lead, and I do oxygen, okay, what would you say the subscripts for lead and oxygen are?
PV2 and just O.
What's that?
PV2 and just O.
You cheated. If you're
do you
doing the
mean I
cross
cheated?
thing, what would you think it would be?
PV2O4.
Right. But if it was Pb2O4, what that would lead you to believe is that oxygen has a -1 charge, and it can't. So it has to be Pb2O. So basically, first thing you have to understand, we're going through nomenclature today, and on Thursday we will start chemical reactions. First thing you have to understand, compounds are balanced with subscripts. These are small numbers below and to the right of the chemical symbol. If you have a parenthesis, the subscript will be multiplied by all the elements in the parentheses are multiplied by the subscript. When we deal with chemical equations, we balance them with coefficients. These are big numbers in the front of a chemical formula. So, bottom line, we have two types of cations. Type 1, the element can only have one possible charge. Type 2, there are more than one possible charge on that ion. When we're dealing with type 1, group 1, all the elements in the first column will always have a +1 charge. Group 2, all the elements in the second column will always have a 2+ charge. There are 4 others I want you to know. Aluminum always has a 3+ charge. Zinc, a 2+ charge. Silver, a 1+. Cadmium, 2+. There is only one polyatomic cation. NH4 has a 1+ charge. It only will have a 1+ charge. Type 2 have multiple charges. If they can have multiple charges, you must use the anion to determine what the charge is on the cation. Charges are always defined for anions, and you can have monoatomic or polyatomic. Monoatomic anions are composed of the same type of element. For example, if we have aluminum oxide, that is Al2O3. There are 3 oxygens, but they're all the same type. So that is called a monoatomic. A polyatomic puts two or more different elements together to make that ion. For example, OH. OH has an oxygen and a hydrogen, different elements, polyatomic. NO3, N and 3 O's, different elements, polyatomic. C2H3O2, different elements, therefore a polyatomic. For the monoatomics, halides have a -1 charge. Halides are the column just next to the noble gases. Oxygen's family, everything below oxygen has a 2- charge, and the nitrogen family, everything has a 3- charge. Guys, I'm not asking you to memorize them. You don't have to memorize them. But what you do have to do is you have to have a page nearby that has these things down there. I'm more concerned with your putting the atoms together than I am with you memorizing these things. It's easy enough to look at. These are the 8 polyatomics I want you to pretty much have in your hand. Acetate, hydroxide, nitrate, nitrite, perchlorate, chlorate, chlorite, hypochlorite. These all have a -1 charge. -2s, carbonate, sulfate, and sulfite. -3s, phosphate and phosphite. If you run into other things, and you will do that at some time, things like permanganate, things like chromate, dichromate, there will be other things, thiocyanate. It's easy enough to look them up. But what I'm telling you is if I ask a question on a test, it will, of a polyatomic, it will be consist of these last three lists. All right. Sorry, I'm just trying to see what this says because right now this is, all right. What you have to know, if we have a neutral molecule, positive charge equals negative charge. So basically what you do is you determine the entire quantity of the charge on the anion by multiplying the subscript of the anion by the charge. That will give you the total negative quantity. You have to understand if there's a neutral molecule, total negative equals total positive. When you get the total positive charge, you divide the total positive charge by the subscript. That will give you the charge of the cation. If the charges match, you're done. Each is understood to have a subscript of 1. So if you mix sodium and iodine, sodium has a +1, iodide has a -1. Just put them together as sodium iodide. If you have aluminum and nitrogen, both of them have 3- charge. Therefore, you have ALN. Okay. I have a 3-pound weight in one hand. I have a 1-pound weight in the other one. Okay? I need to make the weight in both hands equal. I can only put 3-pound weights in my left hand. I can only put 1-pound weights in my right hand. What do I have to do to make the weights equal? Anybody?
You have to add 2 more pounds to your left hand.
I have to,
Or
my right hand.
yeah, your right hand.
I have to add 3 1-pound weights to equal the 1 3-pound weight. So if I have aluminum +3 and I have chlorine, I need 3 chlorines to balance with the aluminum so that I'm now balanced. I have a 2-pound weight in my right hand, 1 in my left. What do I have to do to balance them? Come on.
Yeah. You have to add 1 more pound.
Now they're balanced. So if I have potassium and oxygen, I need 2 + 1 potassiums to equal the 1 2- oxygen. And the hardest one of all, I have a 3-pound weight and a 2-pound weight. How do I make them equal? Come on, guys. Faster we get through this, the more we can get on to something better. I have a 3-pound weight in my left hand, a 2-pound weight in my right. How do I make them equal?
Add 1 more pound to your right hand.
Add 1 more what?
1 more pound to your right hand.
Like this?
I can't see that.
Where am I at? You see it now?
Yeah.
So I'm adding a 1-pound weight to my 3-pound weight.
Oh, whichever one had the 2 pounds in it. Sorry, I keep getting the hands mixed up.
So I'm adding 1 pound to my 2-pound weight. Come on. I have a 3-pound in my left hand and a 2-pound in my right. How do I make them equal?
Would it be easier just to give up 1 pound and?
No, you can't give up. How can you give up how can you, an aluminum give up a 1 charge? It can't. It has to be a 3+. How do we make these equal, guys? I can only put 3-pound weights in my left hand. I can only put 2-pound weights in my right.
Double the
Make it
3 and
equal.
triple the 2.
Triple the 2. So I'm going to put 3 2-pound weights in my right hand. What am I going to do with my left?
2 3-pound weights.
Thank you very much. I'm equal now. If I have an aluminum +3 and I have a sulfur -2, I need 2 aluminums and 3 sulfurs to make them equal. Does this make sense to you all? Are we good with that?
Yes.
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 All right. Now that I dragged that out of you. So if I have aluminum and chlorine, aluminum is a +3, chlorine is a -1. I need 3 times the chlorines. So I have to multiply the chlorine -1s by 3. That will be the subscript for chlorine. The aluminum will stay at a plus at 1. So my formula is going to be AlCl3. If I have magnesium and phosphorus, magnesium is a +2, phosphorus is a -3. You got to use the least common multiple. Least common multiple of 2 or 3 is 6. So I'm going to need 3 magnesiums and I'm going to need 2 phosphoruses. So the formula will be Mg3P2. Now, when you're doing this, the polyatomics must be considered as a unit. Guys, do not, if you have a polyatomic, do not break it up. NO3, nitrate stays at NO3. Keep it together. So, if Mg is a +2, the PO4 is a -3. Again, least common multiple is 6. I need to multiply the Mg by 3. That's going to be the subscript for my Mg. I need to multiply my PO4 by 2. That will be my subscript for PO4. So my formula for magnesium phosphate is Mg3 parentheses PO4 and parentheses 2. You need to put the PO4 in parentheses so that it can be entirely multiplied by the 2. Now, if we have a type 2 cation, okay, if we have a type 2 cation, eventually, in order to name it, we have to know the charge on that cation. So the way we're going to do it is we're going to know what the charge on the anion is. We're going to multiply that charge by the subscript for the anion. That will give me the total negative charge. The total negative charge has to be equal to the total positive charge. Then once I figured out what the total positive charge is, I'm going to divide it by the subscript on the cation. That will give me the charge of that particular cation. Cobalt SO4. SO4, the SO4. There are no parentheses. Therefore, it's assumed that there's one SO4. That has a 2 negative charge. This has to be balanced by a 2 positive charge so that the entire molecule is neutral. That 2 positive is divided by the 1 subscript for cobalt to give me a positive 2 charge for the cobalt. Another thing, guys, when you have SO4, this 4 for oxygen is just modifying the oxygen. If I want more than 1 SO4, I have to put parentheses around it and add a subscript outside the parentheses. Okay, I have Fe2 SO4 taken 3 times. Remember, SO4 has a 2- charge. I have 3 of them. So my total negative charge is -6. That has to equal my total positive charge, which is a +6. But that +6 gets divided by 2. My iron has a 3+ charge on it. Okay. Before I go on, does this seem to make sense to you all? Anybody confused by any of this?
No.
Okay. I'm going to add it here, and I'll probably go and add it again when we talk about empirical formulas in a couple days. An empirical is the simplest ratio of atoms in a molecule. The molecular formula is the actual number of atoms within the molecule. So therefore, you multiply the empirical formula subscripts by an integer, a whole number, and you will get the molecular formula. Carbon dioxide consists of 2 atoms of oxygen, 1 atom of carbon. It's the simplest ratio, and it also happens to be the molecular formula. If I have something like water, water has 2 atoms of hydrogen, 1 atom of oxygen. Again, empirical and molecular formulas are the same. I have hydrogen peroxide. The molecule hydrogen peroxide consists of 2 atoms of hydrogen and 2 atoms of oxygen. So the molecular formula is H2O2, but there's a common denominator there. I can divide both of those subscripts by 2. If I do so, I get the empirical formula of HO. I have glucose. Molecular formula for glucose, C6H12O6. I can divide glucose by 6 and end up with the empirical formula of CH2O. Any confusion, guys? We good?
Yeah.
Okay. Okay. Now we're going to get into nomenclature. How many of you guys had trouble with nomenclature in intro?
I did a little.
I probably did.
It's a systematic thing. I teach it with a systematic thing, and I teach it by your asking questions. Okay? We're going to first name ionic compounds. We're going to name molecular or covalent compounds. Then we're going to name acids. Okay? Now, they're broken down into 3 different portions. Okay? Ionic compounds are distinguished between type 1 and type 2 metals. Binary or covalent compounds have completely non-metal compounds. And acids have a always begin with H. So the first thing I'm going to do, I have a binary compound, which means it has two different elements in it. First question I'm going to ask, is there a metal present? If my answer is no, I have a covalent compound, I use covalent rules. If my answer is yes, that means I have an ionic compound, I use ionic rules. Second question I ask of ionic compounds, I'm going to look at the metal and I'm going to figure out whether or not the metal has a known charge or whether or not it has multiple charges possible. If it can form more than one cation, it's a type 1. I just use the element name for the cation. If it can form more than one ion, I have to define what the charge is, and I name that by putting the element name. Then I put the charge in Roman numerals in parentheses after the cation. So if I have a type 1, if I know what the charge on that metal is, I just name it by calling the element name. If I don't know what the charge is just by looking at it, what I have to do is I have to use the anion to figure out what the charge on the cation is. Then once I figure out what the charge on the cation is, I include that by naming the element and putting the charge in parentheses. So guys, we know it's an ionic compound if the first element is a metal. If the first element is a metal, then what you do is you kind of like block it off. The rest of the entire compound is the anion. Only one exception, and that exception is NH4. It is the only polyatomic cation. So you look at your formula. First thing you do is you look at the first element. Is it a metal? If it's a metal, you're dealing with an ionic compound, use those rules. If it is not a metal, you have a covalent compound. If you have a covalent compound, you use those particular rules. Guys, please always put the cation name first. The two types, we know the charge. Alkali always have a 1+, alkali earth 2+. The special metals, silver is always 1+, zinc is always 2+, aluminum is always 3+. You can include bismuth in there if you want. Bismuth is always a 3+, cadmium is always a 2+. If it is not in any of these categories, then it is a type 2. The charge is not known. Basically, what we're talking about here are the transition metals. So, if I have a type 1 cation, the cation is simply the name of the metal ion. AgCl, the cation silver. CdCl2, cadmium. MgSO4, magnesium. Vera, I just want you to name the cation, Vera.
Sodium.
Or Na2O, what is the cation?
Sodium.
Okay, go to the next one. BaCl2.
Was that barium?
Barium. Jasmina. Next one down.
Silver.
Jasmina.
Yes, hi, silver.
And the last one.
Zinc.
Notice you are not putting any prefix before it, and you are not putting any Roman numerals because these are all type 1 cations. On the other hand, if I have a type 2 cation, I name the metal followed by the charge written in Roman numerals. CuO, okay? I use the O. There's one oxygen. Its charge is -2. That must balance with the copper to be a +2. The +2 is divided by 1. The charge on the copper is +2. So I name the cation copper 2. Iron, Fe3N2. The nitrogen has a -3 charge. 2 times -3 is -6. That has to be balanced with a +6. That +6 is divided by 3. The iron has a +2 charge. It is called iron 2 nitride. Cobalt, COS2. The S has a -2 charge. 2 times 2 is a -4. That must be balanced with a +4 divided by the subscript 1. The cobalt has a +4 charge, so that is cobalt 4 sulfide. Yeah. Done this. All right, we've got half of it named now, okay? Now we deal with the anions. There are 2 types of anions, monoatomic. If it all has the same element, if the anion's made of the same type of element, it's called monoatomic. If there are different elements that make up the anion, it is called polyatomic. To name monoatomic anions, truncate the name of the element after the first syllable, add IDE. So if I'm naming Ag2O, the cation is a type 1, no Roman numeral needed. So the type 1 is called silver. The O is a monoatomic. So the O is oxygen. I truncate the oxygen to ox, add an IDE. So my compound name is silver oxide. If I have a type 2 metal, SnCl2, I have to figure out what the charge on the Sn is. So I multiply the subscript 2 by -1. That gives me a -2. That's balanced by a +2 divided by 1. The charge on my tin is +2. So I name the cation tin, Roman numeral 2. Then the anion is all one element. It's a monoatomic. So I take chlorine. First syllable of chlorine is chlor. Add the IDE. This is tin 2 chloride. Polyatomics are easy. To name them, all you do is just use the polyatomic name. SO4 is sulfate. So ZnSO4 is zinc sulfate. Zinc is a type 1 cation. No Roman numeral is necessary. NO2 is nitrite. So if I have FeNO2 taken twice, the charge on the Fe, because NO2 is a -1 charge, the charge on the Fe is a +2. So this is iron 2 nitrite. Let's try some now. Gabe. First compound is the first element a metal. Gabe. Gabe, did you go away?
Oh no, I'm here.
Okay.
Can you hear me?
AgBr. Is the
Yes.
first element a metal?
Yes.
Do you use ionic or covalent rules?
Covalent.
Is that true, ladies and gentlemen?
No.
If the first, Jasmina, if the first element is a metal, do you use ionic or covalent?
Ionic.
Okay, Gabe, you got that?
Okay, yeah, ionic.
Okay, so is Ag a type 1? It
Yes.
says so up here. Yes. You know the charge is +1. So
Yes.
name the cation.
Would it be silver bromide?
Silver. Then the anion is bromine. Use the first syllable, brom, add IDE. You're right, silver bromide. Vera, the second one.
Yes, sir.
Is the first element a metal?
Yes.
Is it a type 1 or type 2 metal?
So type 1.
Do you need a Roman numeral?
Yes.
Is that true, ladies and gentlemen?
No. Just joking.
Okay, Vera. So, name the cation.
Is it sodium?
Now the anion is monoatomic, so all you have to do is take the first syllable of the element and add IDE to it.
So sulfide.
Sodium sulfide. Good. Let's see. Cassidy. You out there, Cassidy?
Yes.
Is the first element a metal?
Yes.
Is the first element a type 1 or a type 2?
Type 2.
Where's calcium at in the periodic table?
Type 1. It's in group 2.
Does it need Roman numeral?
Yes.
Okay, Cassidy, the difference between type 1 and type 2. Type 1, you know the charge. Absolutely. You say calcium, it's always going to be a +2. I'm lazy, Cassidy. I don't want to write those Roman numerals if I don't have to. Okay? So if
Okay.
you know the charge, just by saying calcium, you know it's a +2 charge. Does that make
Okay.
sense to you, Cassidy?
Yeah.
So if it's a type 1, do you need a Roman numeral?
No.
Okay. What is the cation?
No, calcium.
Okay. Do you know what NO3, the polyatomic name for NO3 is?
Nitrate.
So polyatomics, all you do is name the polyatomic. So what's the name of this whole compound?
Calcium nitrate.
Okay. One more. Kevin. You there, Kevin?
Yep.
This one. Is the first element a metal?
Yep.
Do you, is the first element a type 1 or a type 2?
Type 1.
Do you need a Roman numeral?
No. Oh,
Don't
yeah,
go
you do.
no. Say no. You don't
I
need
don't
a Roman
know.
numeral.
I'm not sure.
Okay, let me ask you this question. Do you know the charge on potassium?
Yeah, it's what, +1?
All right, you're lazy. Aren't you lazy, Kevin?
Sure.
Do you want to have to write that 1 in Roman numerals if you don't have to?
No.
So just by saying potassium, you know it has a +1 charge each and every time. You don't have to write the Roman numerals. Okay?
Okay.
So name, you don't have to use some Roman numeral. What's the name of the cation?
I don't know.
Okay?
Oh, potassium.
Potassium. Now, do you know what the name of the polyatomic anion is?
Sulfide? I
Not
don't
quite. Nope. Somebody help him.
Sulfate.
Sulfate.
Sulfate. Okay. So put it together, Kevin.
Potassium sulfate.
Potassium sulfate. Good. Now, if we're naming a type 2, we got to figure out what the charge is. So we're going to have to figure out the charge on that particular element by using the anion. All right, Jessica.
Yes.
All right. We have lead. Is it a metal?
Yes.
We're using ionic rules. Is it a type 1 or a type 2?
Type. Type
Is
1.
it in the first column?
No.
Is it in the second column?
No.
Is it silver, zinc, aluminum, antimony, or bismuth?
No.
So is it a type 1 or a type 2?
Okay, type 2.
What do type 2s always need?
I don't know.
Do you know the charge on lead?
It can be 2 or 4, right?
Yep. You don't know which one it is, so you have to designate what the charge is by using a Roman numeral. All right, Jessica. Oxygen has what charge?
-2.
How many oxygens do I have there?
So it would be -4.
Okay, that balances with a positive.
4.
How many leads do I have there?
So you just have 1 lead with 4, +4.
A +4 charge. So we now have determined the charge. I need you to name the cation.
Would be lead.
Lead,
Yes.
is that it?
Yes.
Is it a type 1 or type 2?
Type 2.
So what do type 2s need?
Roman numeral.
The Roman numeral. So this would be lead.
Oh, I'm sorry, 4.
Lead 4. All right, now let's get the anion here. What's the element?
Oxygen.
All right, first syllable of oxygen.
I don't know what you're asking.
You know what I'm talking about with syllables? Okay, my name is Popovich. Basically, there are pauses. Pop, first syllable, O, second syllable, Vich, third syllable, okay? So
Okay.
oxygen also has 3 syllables. What's the first syllable?
Ox.
Ox, then add IDE.
Okay, oxide.
So the whole name of your compound is lead 4 oxide. Does that make sense to you, Jessica?
Yes.
Okay. I got Ni2SO4 taken 3 times. And I'm running out of people I haven't called on. Ian, you out there, Ian?
Yes.
Okay, is nickel a metal?
Yes.
Does that mean it's an ionic compound?
Yes.
Yes. Is nickel a type 1 or a type 2 cation?
Type 2. I don't know though. I did not write
Okay,
that down.
Ian, easy way to find out. Is nickel in the first column?
No.
Is it in the second column?
No.
Is it zinc, silver, aluminum, bismuth, or antimony?
No.
So is it a type 1 or a type 2?
Type 2.
Type 2. That means we don't know the charge. Type 2 metals always need what beside it to name it?
Compound.
Somebody help him. What do type 2s need?
They need the charge and the Roman
They
numeral.
need the charge and Roman numerals, Ian. Okay?
Got it.
All right. Now, SO4 has a 2- charge. How many of them do we have, Ian?
Repeat that again, my bad.
SO4 has a 2- charge. How many
Right.
SO4s do we have?
2.
Look where the arrow is.
3. My bad.
3. So the total negative charge is 2 times -2 times 3. That makes a -6. That -6 balances with a +6. How many nickels do I have?
2.
So what's the charge on each nickel?
-2.
No, it's not negative. It's a cation. Cations are always positive. I've got 6 plus divided by how many nickels do I have?
2.
2. So 6 divided by 2 is?
3.
So name it. Ian, what's the name of the metal?
Nickel 2.
No. What did we say the charge was, Ian?
Plus 3.
So nickel 3.
3.
SO4 is called sulfate.
Nickel 3
So-
sulfate.
So this is going to be nickel 3 sulfate. Quickly, I want Cassidy to do number 1, Gabe to do number 2, Jasmina 3, Jessica 4, Kevin 5, Layla 6, Vera 1, and Ian 2.
Could you tell me what number 1 says? I saw it for a second, but now there's like a weird.
Yeah, me too.
Okay, now I can see
Okay,
it.
thanks.
Yeah, what happened was, what I was doing was I was pulling up the participants to make sure I got everybody, okay?
Oh, okay, so number 1 would be manganese 2 nitrate.
Good. Who's got number 2?
I do. Is it antimony, right?
Yep.
Would it be antimony phosphate?
Antimony is one of the special ones. Always is a +3. You're right. Third one.
Is
Who's
it?
got number 3?
I do. Is it?
Okay, Jasmina.
Is it copper 4 oxide?
Nope.
I didn't have enough time to find out whether it was type 1 or type 2. If not, then just
Is it-
copper
all right.
oxide.
We're going to go through this together, Jasmina. Is it in the first column? Is it
No.
in the first column, guys? Or Jasmina? Is it in alkali?
No.
Is it in the second column?
No.
Is it silver, zinc, aluminum, antimony, or bismuth?
No.
So is it a type 1 or a type 2?
Type 2.
What do you need with type 2?
A Roman numeral.
How do you find the Roman numeral?
Oh wait, copper 2.
Nope.
What?
What's the charge on oxygen, Jasmina?
-2.
So -2 balances with a +2. You divide the +2 by how many?
Oh, so that just copper 1 oxide.
There you go. Good. Good for you. Who's got number 4?
I do, but I can't see. My screen is really blurry.
Okay.
I don't know what it says.
Cr parentheses C2H3O2, which is acetate, end parentheses 4. Acetate has a -1 charge. There's a subscript of 4. What is the total negative charge there?
Okay, you said CR parentheses C2H what?
3O2. C2H3O2 is acetate. Okay.
Right.
Acetate, each acetate has a -1 on it. How many of them do we have here? Can you see that?
No, my screen is really
Okay, each one is a -1. The subscript is 4. So what's the total negative charge?
-4.
-4. That balances with a +4. There's only 1 for the subscript of chromium. So the charge on this chromium is a +4. So you name it chromium 4 acetate. Who's got number 5?
I do.
You got it? You have the name?
I think it's mercury 3 nitride.
Nope. Each nitrogen has a -3, right?
Yeah.
3 times 2 is a -6. That balances with a +6.
Oh, mercury 2.
There we go. Absolutely. And who's got the last one?
I do tin 2 phosphite.
Tin 2 phosphite. Okay. Now we're going to do this again. Jessica, you have 1. Ian 2. Cassidy 3.
Can you tell me
Gabriel
what
4. Jasmina 5. Kevin 6. Layla 1. Vera 2. Now I want you to derive the formula from the name.
Can you tell me what number 1 says? Because I can't see it.
Potassium hydroxide. What's the symbol for potassium? Is this Cassidy?
It's Jessica.
Jessica, sorry. What's the chemical symbol for potassium?
K.
Do you know what hydroxide's symbol is?
H or O.
Let's give a guess, okay? Hydro. What do you think? What do you think the other element is?
Acid.
Nope. This is a base, Jessica. But you have hydro. What element do you think hydro would be? What do you think hydro would be a symbol of?
Oh, sorry, H.
H, oxide.
O.
So it's OH. So the formula is going to be KOH.
Okay.
Make sense, Jessica?
Yes, sir.
All right, tin 4 chloride. Who's got that? Ian?
SnCl4.
SnCl4. Iron 3 acetate. Who's got that one?
Me, Fe parentheses C2H3O2 parentheses 3.
Good. Aluminum sulfate. Who's got aluminum sulfate?
Got mine.
I'll skip it then. Number 5, nickel 3 nitride.
Is it just Ni and then N?
NiN. Barium sulfide. Be careful.
Oh, you scare me now. I got BAS.
BAS. Some people like to see the sulfide and they'll put SO3 or SO4 there. Okay? Now, guys, I'm a little bit behind. Would you mind staying another 15 minutes or so?
No.
I have class at 11.
Okay. Then the only thing I can tell you is to just look at the video. I will put the video up.
Okay.
Fair enough?
Yeah, it's perfect.
I just need to get through the naming molecular compounds and acids.
All right.
Okay?
Perfect. Thank you.
Now, guys, if you're looking at a compound and you ask yourself, is a metal present? If the answer is no, you're dealing with covalent compounds, you're using covalent rules. Ionic rules, no prefixes. Covalent rules, prefixes. All right? Once you have a binary compound, you look at the first element. If it only has one atom, just name it. If it has more than one atom, you precede it with the right prefix and add the name. Then you look at the second atom. The second atom always has a prefix. You use the prefix, then the first syllable for that element, end it with IDE. So if we have something oxygen, that would be, if there are 2 oxygens, di is the prefix, ox is a root, IDE. So it would be dioxide. The prefixes we're going to use: mono for 1, di 2, tri 3, tetra 4, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca, 11 predicata. You will never have anything with 11. All right, so if we're dealing with a molecular compound, we looked at the first element. The first element is a nonmetal. We are dealing with covalent rules. The first element, there's only one of them, so there is no prefix. So you just name it, carbon. The second element is oxygen. The body of the second element is OX. The subscript is presumed to be 1, so the prefix is mono. End it in IDE, monoxide. The compound name is carbon monoxide. First element, nitrogen. It is not a metal. Use covalent rules. How many of them are there? There are 2 there. The prefix for 2 is di. So that becomes dinitrogen. Look at the second element. There are 4 of them there. The prefix is tetra. The root is OX, ended in IDE. Dinitrogen tetraoxide. Remember, if there's a metal in the formula, do not use the prefixes. If there's a metal, this is an ionic compound, use those rules. Okay, we're going to go with I lost 5 people. Cassidy,
Yes.
is the first element a metal?
No.
So are we using covalent or ionic rules?
Covalent?
Do we use prefixes?
Yes.
Okay. How many of the first elements do we have?
4, so it's tetraphosphorus decaoxide.
There we go. Vera.
Wait, sorry, I had a question. My teacher from Intro Chem said when you have things like tetra and oxide, rather than writing the A, you could just write like tetroxide. Is that okay, or did you want us to put like tetraoxide?
How did he say to use the O or use the A?
To use the O rather than the A.
Yes. When you got 2 vowels together, it just doesn't look good.
Okay, that's what I thought. I just wanted to double check before I went and did that.
To be honest with you, I probably wouldn't take it off.
Okay, thank
Is that
you.
Cassidy? Cassidy?
Yes.
Okay. Vera,
Sir.
SBr4, BR6. Is the first element a metal?
No, it's a non-metal.
So we use covalent or ionic rules.
Use covalent.
All right, look at the first element.
Sulfur.
Sulfur. Second element, how many of them are there?
There's 6 of them. That's bromide. So sulfur hexabromide? Or
There you go.
Hexabromide?
Okay, Jasmina.
Aye.
Cl2S7. Is the first element a metal or a non-metal?
Non-metal.
Do we use covalent or ionic rules?
Covalent. So
So
it's
are we using
dichloride.
prefixes?
Yeah, dichloride heptasulfide.
Almost. You don't use an "ide" for the first element. So it's dichlorine heptasulfide.
Oh, gotcha.
Okay?
Yeah.
Who thinks they got this stuff down?
think just
Kevin. You think you got this stuff down?
No.
Okay. I'll call somebody else then. Jessica, you can't read the screen. Vera.
Sir.
I wrote it down. It's I can kind of, it's going in and out. It's
CaBr2.
so it's a metal and a non-metal.
Good catch.
Which
a lot of people see Ca, and I don't know what about it, but a lot of people just assume that is a non-metal. So it's a metal. How do you name it?
So it would be ionic. Would it be calcium dibromide?
No.
Oh.
We're using ionic rules. Ionic rules do not use prefixes.
Oh, okay. You're right. Calcium bromide.
There we go. Okay, give it a shot. Kevin, Ci. Is the first element
carbon monoiodide.
There we go.
Excuse me, where is this slideshow in your, where can we find this slide that you're going?
Are you not seeing the screen?
No, I see it, but is there any way I can access it personally?
Yeah.
Like through my courses.
Yeah, Kevin, just hold on. I will show you where it's at when I finally end the
It's
slideshow, okay?
It's under chapter 3.
Oh, okay, that's why I can't find it. Okay, thank you.
Well,
all right, I want the formula. Jessica, I'm going to hold you off on you for a second. Cassidy, carbon dioxide, what's the formula?
CO2.
Go again, sulfur tetrafluoride.
SF4.
SF4. Dichlorine heptaiodide. We're going to go with Kevin. Dichlorine. How many chlorines do you have?
2.
Heptaiodide.
Is that 8? Is that 8?
Not quite.
Not sure then.
Not quite 8.
7.
7.
So it's Cl2I7.
Yes. Do you know why Tim was nervous? Kevin, do you know why Tim was nervous?
Oh,
7, 8, 9.
oh yeah, yeah.
Okay, Vera. We're going
Sure.
to go with number 5. What is number 5, Vera?
Is it H2? Wait. Is it H2? Wait, monoxide.
Monoxide.
So
How many of them are there?
One.
One what?
One oxygen.
So what's the formula?
So is it H2O?
It's H2O.
Oh,
That
see
is the formal name for water.
Oh. It just looks poisonous. It said monoxide. So like, yeah.
There is
Okay.
an amount of oxygen. There is an amount of water that you can consume and die from it. It's called
Okay.
drowning.
Okay, I
So
got
it
you.
is toxic.
Okay.
All right. Last thing I'm going to go through, guys. Naming acids. You have to understand the formula will always begin with a hydrogen. There are 2 types of acids. Binary, meaning there is the H plus one other type of element. There's also another type, and that is the oxyacids. An oxyacid will have an oxygen in the polyatomic anion. So basically, look at the anion when you're naming acids. Does it contain oxygen? If the anion does not contain oxygen, then all you do is name the acid by putting hydro, then the root of the element, first syllable of the element, add IC and acid. If this is HCl, hydrochloric acid. If it's HBr, hydrobromic acid. If the anion contains oxygen, you got to check the ending. And I've got a mnemonic for this that I'll show you in a second. If the ending of their polyatomic is ITE, then it is just the root OUS acid. So if this were NO2, that would be nitrite. Drop the ITE, add OUS, nitrous acid. If the anion ends in ATE, again, you do the root IC acid. So SO4 is sulfate, drop the ATE. It doesn't count, sulfic acid just doesn't sound good. So you add another syllable, sulfuric acid. So just going here. This acid, H2S, it's a binary acid, consists of only, the anion consists of only one type of element, the S. So it's a binary acid. You start with hydro, the first syllable of the element that's not hydrogen, sul, then you add IC. Hydrosulfic acid does not flow off the tongue, so it becomes hydrosulfuric acid. Guys, there aren't that many of them. When we're dealing with binary acids, I'm going to move up here for a second. When we're dealing with I don't have a periodic table on this. When we're dealing with binary acids, We don't have that many of them. There is nitrogen doesn't even count because NH3 is a base. Water, again, is not an acid. So there's HF, hydrofluoric acid. There is H2S, hydrosulfuric. There is HCl, hydrochloric. H2SE, hydroselenic acid. HBr, hydrobromic, and HI, hydroiodic. Those are the only ones you really have. Questions, guys? Last thing are the oxyacids. Those are going to be the polyatomic anions. You got to remember a mnemonic. I ate it and it was icky. If your polyatomic ends in ATE, change the ATE to IC and add the word acid. You may have to add a syllable. Okay, SO4 is sulfate. Drop the ATE, add IC. Sulfic doesn't sound good, so just add another syllable to make it sulfuric acid. HNO3, the anion is NO3. That is nitrate. I ate it, it was icky. Change the ATE to IC, you have nitric acid. On the other hand, if you have another one, you took a bite and it was delicious. If the anion ends in ITE, change the ending to OUS and add acid. So I have HPO3. The anion is phosphite. I took a bite and it was delicious. So phosphite gets changed to phosphorus, add the acid. HPO3 is phosphorus acid. HNO2, the anion name is nitrite. I took a bite and it was delicious. Change the ITE to OUS, nitrous acid. And I know I went through these acids very, very quickly, guys. Do you have any questions? If you have questions, I would first go to the video. Anybody have any questions? How many lasted till the end? I got 4 people still in here. Any questions, guys?
I don't have any.
I think it's going to take practice. A lot of.
All right. The practice. Guys, look at the extra homework. The homework doesn't get into this, into near the detail that you need. You need practice on this. Yeah, I know it's boring as hell, but you need practice on this stuff in order to be able to do this like that. And literally speaking, you don't want to be in a test and having to just scratch your head when you see a formula and you need to know, or if you're given the name, to put the formula down. You don't want to be scratching your head for a while, so you need to get this down. That's my biggest set of advice. Definitely the MyLab and Mastering homework on this does not nearly go into it nearly enough. I would use the practice extra homework. Now, Kevin, you were asking where it was? Kevin, you still there? Kevin's buggered out.
He's gone.
Thank you very much for indulging me the extra 25 minutes, ladies and gentlemen. We are now caught up with the other class, for sure.
Awesome. Thank you.
Okay. Our test is on September 15th. It's still at that date. If you guys did not turn in your lab notebook to the Dropbox, do it. You have until tomorrow midnight. Okay? That's from people that have me in lab. If you don't have me as a lab instructor, then you have to negotiate with your lab instructor. Okay, guys, that's it.
Thank you. Have a good day.
You have a good day.
Thank you.
We'll see you
Bye-bye.
guys later then, all right? I
Yep,
really hope
see you.
this helped.
Thank you.
It does a lot. Thank you.
That's good.
Yes, sir.
Take care, guys.
You too.
Go ahead. I'm still here, Vera.
No, I had a quick question
Sure.
about the extra homework. Last week, like you had one that had you had like a sheet where we have to like draw out the electrons and all that stuff. Is that going to be part of the test, like
Okay.
the electron configuration?
No, wait. You're asking two different things there. I think what you're talking about is drawing the Bohr atom.
Yeah,
You
yeah.
are responsible for the Bohr atom.
Okay, but
All right.
now that's for the first 20 elements though? Because after that,
Only the first 20, only
Okay.
up to calcium.
okay, okay. And you said like with the PowerPoints, like you recommended like printing them out and writing notes on them as you go along, so that way you can use it for the test, right?
Yes.
Okay, gotcha.
You're allowed to use if they're printed out, you can use them. What you're
All right.
not allowed to do is use a browser.
Right. Okay. And
Okay.
my last question with the periodic table, is that something we should have printed out as well?
No,
Or will that?
there will be a periodic table included.
Okay.
And the reason I jumped out and said no is that I would like you to use the atomic weights that are on that periodic table.
Okay.
The last question of the test
Hmm.
is going to be the periodic table.
Okay.
And the funky thing about it is I can't put it in there without giving it a point value.
Right.
So I have to call it 1 point. Now, if I call it 1 point, this means that I had to take a point away from the first question. So the
Right.
first question is labeled 1 point, but it's actually 2.
Okay.
Fair
And
enough?
yeah, and since we're kind of on the topic of like the atomic mass, because I noticed on some of the questions on like Pearson and like some of the homework, like would you ever round up the masses, like if it's close to like the next?
What you do, and I'll get into this when we talk about moles and things like that.
Okay.
All right. Say my data. Say I recorded a weight of something like 75.1 grams.
Right.
Then I don't want to lose any significant figures of my data.
Right.
So my data has 3 significant figures. If I have like carbon dioxide, I have 75.1 grams of carbon dioxide. I can't use 12 for the carbon.
Okay.
Okay. I can't use 12 for the carbon because 12 would limit my sig figs.
So then you would use a 12.01 then.
Yes.
Okay. Gotcha.
Does that make sense to you, Vera?
Yeah, it does. It does. Sounds good. Thank
Okay.
you, sir. Yeah, good.
Good enough.
All right, thanks.
You take care. I will see you next Thursday or this Thursday.
I work this weekend, so I'll be watching the video.
Okay. Again, you've been able to access them?
Yes, sir.
No problem.
All right.
This will be, it may take a while for this to get uploaded, but it will be uploaded.
Okay.
All right.
Well, thank you.
You take care then.
All right, you too.